Question 13a says, in the diagram above, the radius of the sector of a circle with center O is 7 centimeters and angle MON is 60 degrees. Find correct to one decimal place the area of the shaded portion. Let's go back to the question again and see all the information we can get out of this write-up. So we have, in the diagram above this diagram, the radius of a sector of a circle with center O is 7 centimeters. That means this is our center O and this is like our sector. This is part of the circle that goes right round. It looks like 1/4 of it. It's a portion of a circle that goes right round. Looking at the diagram, we can see from O to P is 7 centimeters. We can also, because math is sometimes like a puzzle, you have to find out all the information from the question. So if this to this is 7, and the radius runs from the center to the circumference of a circle, that's a line that runs from the center to the circumference. So from O to P is the radius. We'll also notice that from O to N is a line that runs from the center to the circumference of a circle. So if this is 7, then this is also 7. And this line from here to here is also 7. So from O to M is 7, from O to P is 7, and from O to N is 7. We can note that first. This is 7 centimeters. And this O line is 7 centimeters. We'll see how this will help us solve the question. We've now discovered that our O to P is same length as our O to N and our O to M. So O to P equals O to N equals O to M, which are all the radius, which are all 7 centimeters. Knowing that an angle MON is 60 degrees, so this angle is 60 degrees. Find correct to one decimal place the area of the shaded region. This is the shaded region. We have NTM as the shaded region. We know this is not a regular shape and we can't easily find the area. We need to find the area of two things to get the area of this shaded region. And a close look at this diagram shows there's a big sector and there are two other sectors inside. We have the big sector, which is OPNM through T back to O. And in it we have a smaller sector, which is OPN. This is the sector here. Then we still have another sector, which is this, where the angle of 60 degrees is given to us. This 60 degrees is going to help us solve the question. So this is another sector that goes right round. We have that ONM through T to O. So looking at this, we can now find the area of our shaded region, considering this particular sector with the angle given to us. For the bigger sector, the angle is not given, but we have the angle for this. And for us to find the area of the shaded region, we'll find the area of this sector, also find the area of this triangle, and subtract the area of the triangle from the area of the sector to get the shaded region. For example, let's say the area of this sector, for example, is 20 centimeters squared. The area of this triangle should be less, which let's say is 15. For you to get the area of the shaded region, you have to take the area of the triangle away from the area of this sector, which will be 20 minus 15, which will give us 5. Same applies to this. The area of the shaded region is equal to area of the sector in bracket MON minus the area of the triangle ONT. We know for us to find the area of the shaded region, we need the area of the sector and the area of the triangle, and subtract the area of the triangle from the area of the sector. And the particular sector we're talking about is the one that runs from O through N, takes a curve at M, and back to O through T. So that's our sector. We have our angle, and area of a sector is theta over 360 times pi r squared. Therefore, area of sector NOM is, since we know our angle is 60, that's 60 degrees over 360 times 22 over 7 r pi times our r. We know our r is 7, so we have 7 squared. We can cut down the 0 cancel 0, 6 here 1, 6 here 6. We have 1 over 6 times 22 over 7 times 7 times 7. 7 squared is 7 times 7. This 7 can cancel out this 7. So you have 22 times 7 over 6, which would give us 25.667. To 1 dp, as to 1 decimal place, we'll have 25.7 cm squared. Now that we have the area of sector ONM, we can now find the area of this triangle ONT. There are two ways to find it. We can, since it's a right angle triangle, we can do the usual half base times height, or we can use half AB sine C. I think using half AB times C will be faster, and our A will be 7 centimeters and our B will be the base below. For you to use this formula, the angle you're going to use, your angle C, will be the angle that connects both line A and B. Let's say this is our triangle. We have here to be 60 degrees. We have here to be 7 centimeters. We can use half base times height. This is our height. To find our height, we'll find our base using Pythagoras theorem. Or we'll find our base still using Pythagoras theorem and use this 60 to solve. So let's just find our base first. Since it's a right angle triangle, we have this as 7 centimeters, and this is our opposite. The line facing the angle you're given is the opposite, and the last one is the adjacent. The one facing the right angle is the hypotenuse. We are looking for our base, which is B, and the formula says cos theta equals adjacent over hypotenuse. Cos 60 degrees equals, our adjacent is B, our hypotenuse is 7. B is like over 1, you cross multiply. B times 1B, then 7 times cos 60 is 7 cos 60. B equals 7 times cos 60 is half, or 0.5. So B is 7 over 2. B is 3.5 centimeters. Now we have our base to be 3.5 centimeters. We can then apply the formula for finding the area of a triangle that says half AB sine C. This is our diagram. We have here to be 60 degrees. We have this part to be 7 centimeters, and we have this part to be 3.5 centimeters. For you to apply this formula, because I'm emphasizing on it because students need to understand when this formula can work for finding the area of a triangle. Note, the angle should be between the two other sides that are given, not between this and the opposite, for you to apply this particular formula for finding the area of a triangle. So using this formula, I can say half, our A is 7 and our B is 3.5 sine, your angle is 60 degrees, that's sine 60. We have half times 7 times 3.5 times sine 60 is 0.8660. To the next, we multiply this to 7 times 3.5, 24.5 times 0.8660 over 2. We multiply 24.5 times 0.8660. It gives us 21.22. Still divided by 2. 21.22 divided by 2 gives us 10.6 centimeters square as the area of the triangle. Now we have both the area of our sector, which is 25.7 centimeters squared, and the area of our triangle, which is 10.6 centimeters squared. And like said earlier, for us to find the area of the shaded region, we need area of the sector NOM minus area of the triangle ONT. Area of the shaded region is equal to area of the sector is 25.7 centimeters squared, while the area of the triangle is 10.6 centimeters squared. We therefore have 25.7 minus 10.6. It gives us 15.1 centimeters squared to one decimal place, as the area of the shaded region TMN.